Hey guys, let's talk about new problem today from dynamic programming, which is called 0-1 knapsack problem. So you would be having two variants of 0-1 knapsack problems. First one is bounded and second one is unbounded. So currently all the questions what we have seen in this pattern, like subset sum, target sum, count number of subset sum, right? Subset difference, minimum difference. So all these will come with the 0-1 knapsack problem category, where either you pick that element or you don't pick that element. And then the next series, next pattern what we will be starting will be the part of bounded knapsack. Okay, so here see in 0-1 knapsack problem, this is the classic dynamic programming problem where each item can be chosen either 0 or 1. Okay, now let's say you have given one weight array, okay, weight of particular elements, and then value array. So in this problem, you would be given one weight array, value array, and then one weight, capital W. Okay. So now what you need to do, maximize the total value without exceeding capacity W. So it means that you have a knapsack, okay, where you can have a maximum number of weight is capital W in that. Okay. Now you have different weights with you. Like for example, this is 1, 3, 4, 5. These are the weights, okay, and this is the value of these weights. What are the value? For one weight, the value is 1. For 3 weight, value is 3, 5, 7. Okay, so now and capital W is 7. So you need to you can have at max 7 weight into that knapsack. Now you need to pick weight such that the value should be maximum, but the weight should be minimum, right? So how you can solve that? See, in this question, if you see, if you pick items 3 and 4, okay, this 3 and 4. So what is the value for this 3 and 4? The summation of 3 and 4 is 7, which is the weight given. Okay, so this one is satisfying the condition, and the value is 4 plus 5 is 9. So can you pick anything else whose sum is equivalent to 7? Okay, weight is equivalent to 7, but the value is maximum. No, right? This is the one only. So this is the answer. Now how you will figure out this? Very simple. See, you create one 2D array. Okay, here you take a weight. So here you take a weight is 1, 3, 4 and 5, and let's take its value also. Okay, so this one will be 1, this one will be 4, this one will be 5, and this one will be 7. So this is value, this is weight. And now here your total weight is 7. So 7 means you start from 0, 1, 2, 3, 4, 5, 6 and 7. Okay, now now here what you will do? See, this is the either if you include that item or if you don't include that item. So this is the same recurrence relationship what we have used for subset sum, target sum. Okay, we will see that how we will derive it. Okay, and then here if you see the question also, okay, so everything is similar like what we did. Now let's come to the table format. Okay, let's say you have a weight 1, okay, and you need to form 0. So how much weight will be taken? 0, right? Because you will not take this 1, right? 0 weight only. So 0, 0, 0, 0 will come here. Now tell me one thing. If you have one weight, okay, and by the way, just keep in mind in this 2D array we will be writing values, okay, in terms of values and not in terms of weight. So we calculate in terms of weight, but we will write value accordingly. So we will see how. So see, you have a weight, okay, this is your weight and this is your capital W. So now this is value, this is weight. So now let's say you have a weight 1 and you need to form weight 1. So how much weight will you take? 1, right? So 1 means 1 into 1, the value. What will be the value? Okay, 1 into 1, so 1 will come here. Now let's say you need to form 2, okay, 2 weight, and you have only 1 weight, and we can take one item at once only. We can't take again, right? So you will take only once, right? So 1 into 1, 1 into 1, 1 into 1. We are writing here values, okay? So if you are taking 1 weight and 1 weight value is 1, so 1 into 1, right? If you okay, now tell me one thing. If you have a weight 3, okay, and you need to form 1, so what you will do? See, currently the weight is lesser than my this left hand side weight, right? So what I will do, whatever I have calculated previously, I'll take directly that. Okay, so because 3 is greater than 1, so we will take directly this value 1, because we will, in that case we will take this item, right? We will not take this item. And then here also 1. Now here tell me one thing. If you have a weight 3 and you have to form weight 3 only, right? So 3 minus 3. If you take this item, so 3 minus 3, what is remaining? 0. Let's go to one step up, okay, and then check what was the value for 0. So one step up means this row, and here this is 1, 2, 3. 3 step back means 0. So the value is 0. So 0 and and here you will take 1, right? So 1 plus 0, 1. The answer will be 1 here. Okay, now again check for 4. So 4, okay, 4 minus 3, 1. Let's check what is the value for 1. It is 1. So 1 plus 1, 2. So 4 minus 3 plus 1, okay, 2. And not 2, I'm sorry, here we will be calculating values now. So here 1 means, so 1 means 4, correct? 1 means 1 only. We are taking the direct value. So this 1 is correct, this 1 is correct. Here this one was 4 plus 1. So here, see, here you have a 3 minus 3 means you took 3 ones, right? You took 3 first, and then you went 3 step back, so it was 0. So for 0, this was 0 only. Okay, but here so we are calculating in terms of value. So what is the associated value for 3? 4, right? So we will write here 4. What is the associated value for 0? 0 only. So here 4 will come. We are writing in terms of values. Okay, so now here 4 minus 3, 1. So first so you are taking 3, and then 4 minus 3, 1. So what is there on 1? 1. So this one will be as it is, but this 3 will be equivalent to the value is 4. So you will not take this 3 but 4. So here 5 will come. Okay, similarly plus 1 do 6, 7 and 8. Okay, now it's time for 4. So 1 is lesser than 4. So take whatever you have here. Okay, 1, 4. Now here you took 1, 4. So now what is remaining? So total weight you were having, capital W was 4, and now you took 1, 4. So what is the remaining? 0. Okay, so on 0th row here, what is the answer? 0 only. Okay, so but you will not write 4, you will write it's a value. So value is 5. So 5 will come here. Okay, and then see, 5 is here, 4 is here, so you will take 1, 4. Now 1 is remaining, so for 1 this 1 is there. Okay, so for 4 what you can write 5, and for 1 6. So here 6 will come. Okay, then similarly 7 and 8. Okay, 7 and 8, correct? 6 minus 4 means 1, 4, 5 will come, and then 2 is remaining. So for 2 what is the answer? For 2 the answer is 1, so it is 6. So here you need to check one more thing. Either you will take the value, the above value, or you will take that element and go that step back. Okay, so whatever is maximum, you will take that value. So here also, if you check, here we are finding the maximum, right? So whatever is maximum. So till here, so we were not required it. Okay, it was directly coming the value. But here, if you check, so here see the total weight is 5. Okay, and you have 4. So you took 1, 4. So for that the weight was 5. Okay, now 5 minus 4 is 1. So for 1, what was the value? It is 1. So 6. So we have written 6. Here also it was 6. So we don't need to take directly that value. But here for this 6, okay, for this 6, and your weight is 4. So 6 minus 4, what is the remaining weight? 2. Okay, so you took this 4. So what is the equivalent value for this 4? 5. And for this 2, let's go one step up, and then let's check what is the value for 2. It is 1 only. So plus 1. So this is 6. But what is the value here? 7. So that's why we have taken directly that 7 value, and we ignore that 6 value. Okay, same thing will happen for this 7 minus 4, 3. Okay, so for this 4, so 5 will come, and for 3, what is the value? For 7 minus 4, 1, 2, 3, 4. Okay, so for this 4, the value was 4. So 4 plus 4, 4 plus 5, 9 will come here, not 8. Okay, 9 is greater, right? So 9 will come here. So now here, okay, now let's check for this last row. Okay, let me remove this unnecessary code. Okay, you don't need it. Okay, now let's check the last row. So what is the last row? Again, let's check. So you have to form 1, and you have weight 5. Actually, you don't have 5. You have 1, 3, 4, 5. So till 4, so you have already calculated. That's why you are taking directly that value. Okay. So for this 5, 1 is lesser. So you will take whatever you have here. So for 2, 1 will become here. For 3, 1, 4 will become here. As it is, I have taken. Okay. Now for 5. So for this 4 also, 5 directly will come here. Now for 5, you have taken 1, 5. So now 0 is remaining. So for 0, it is 0 only. Because you took 5, so the value is 7. So either you take 7 or 6, whatever is maximum. 7 is maximum, so 7 will come here. Okay, now for 6, 6 minus 5, 1, and what is the value for 1? It is 1. So 1 plus 7, 8. Okay, so you will write here 8. Now for 7, 7 minus 5 is 2. So 2 is 1, right? And it was 7, 7 plus 1, 8. But 8 and this one is 9, so I'll directly take this value, 9. So here, this is my answer, 9. Okay, 9 will be my maximum weight. 4 plus 3. So see, you will take 4 and 3, and its value is 4 plus 5, which is 9 only, right? Now you need to find the weights also. So how you can find? See, let me clean this. So you have array something like this, 9 and 9. So how this 9 is coming? We are coming from here, right? And then how this 9 was coming? This 9 was definitely not coming from this above. Okay, so we were going, what is this? 4. So we were going 4 step back. So this is 1 2 3 4, we have taken from here, right? This 4. So this 4 will come into the picture, into the array. So 4 will come definitely. Okay, now how this 4 is coming? It is not coming from here, it is coming directly from here. So you will jump here. Okay, and then how this 4 was coming? This 4 was coming, you were having this 3. Okay, means how this 4 was coming, it was coming from here. And how this 4 was coming, so you just go to 3 step back. Okay, so because you jump from here to here, so this 3 will also come, and then you will go up and 3 step back, 1 2 and 3. So you reached here. Okay, so your answer will be 4 and 3. So this is how you find the 0-1 knapsack problem. You understood the recurrence relation, right? So dp of iw, if you do not include that, so you take directly whatever in the above value, I minus 1 w. Okay, and then if you take that value, so take the dp of I minus 1, whatever you have, and then w minus w, weight I minus 1. So this is what we have seen, right? Means this is value of I minus 1. So whatever value you have here, this one, right? You minus this now, and then you go one step up, and you will just subtract that weight, okay, from above. So that is what we are doing. We are taking that value as it is, plus you are going one step up and then subtracting that weight from the actual weight. Okay, from the actual weight means let's say this one, or this one. This is weight only, right? So your final formula will be whatever is maximum, either this or this. This is what we did, right, in the trial run. And this is the knapsack code. Okay, so what you will do, you would be given one weight array, value array, and capital W. Okay, and then means knapsack capacity, and then you will find the size of the weight. You will create one dp array. Okay, size will be n plus 1 and w plus 1. Why? Because we are taking zeros. Now you can take 0 actually both side, row and column wise. Okay, so now you run 2 for loops. Okay, one for I equal to 1 to n and w, and then you check if weight of I minus 1 is less than w. Okay, then to just check whatever is maximum, otherwise take directly the value from above, because let's say this is your 5 and here it is 1, so 1 is lesser, so we were taking directly the value, right, whatever was here. So that was the condition here, this one. Okay, and then at the end, whatever is the last row, last column, you just return that value. And the space complexity and time complexity will be order of n cross w, where order of n is the size of value array, w is the size of w array. No, this is capital W actually. Okay, now this is the space optimization. Okay, instead of 2D array, we will take 1D array. And so here I was talking about this thing, right? So if you do this 0-1 knapsack problem, okay, then this subset sum problem, partition equals subset, target sum, minimum subset, these all are similar only. Okay, the recurrence relationship in fact is the similar. So you will complete 5 questions if you do this one question. So that's it. Thank you.